Hello everyone, welcome to our presentation. I'm Amirhosein-Mansouri from Shahid University. Today I will share our work on project-based engineering education for e-learning wind turbine control system using handcrafted models. I will be presenting on behalf of my colleagues from Iran, Thailand, and France. I hold Bachelor of Science in Mechanical Engineering from Roghayeh University and Master of Science in Renewable Energy Engineering at Shahid University in Iran. My research focuses on renewable energy systems, particularly DC microgrids, and how they effectively teach these concepts to students. Our presentation is made up of four sections. After the introduction, the proposed method is explained, the results are presented, and finally, it ends with conclusion. Let's start with introduction section. Due to the challenges of global warming, the importance of renewable energy has significantly increased. The main type of renewable energy include solar energy, wind energy, geothermal energy, hydrogen energy, various forms of blue energy, and biomass energy. As the role of renewable energy become more critical, educating people about these technologies is also essential. In this research, we present an innovative method for teaching some key concepts of wind energy, aiming to make learning both more engaging and more effective. The mechanical energy of wind strikes the blade of a wind turbine and is converted into electricity by the generator. Although this electricity is of AC nature, due to the fluctuations in wind speed, its waveform is not a standard sine wave and therefore cannot be directly used. Throughout a control system known as back-to-back, the generated current is first converted to DC and then back to AC. This process ensures that the wind-generated electricity can be synchronized and safely connected to the main power grid. Since energy engineering is an interdisciplinary field, teaching concepts like the ones we have just discussed requires a creative approach. Students entering these fields often come from a variety of academic backgrounds, which means their prior knowledge and perspective can differ greatly. Therefore, educators must design teaching methods that not only explain the technical details clearly, but also engage students from diverse disciplines, ensuring that everyone can connect with and understand the materials. At Shahid University in Iran, during two consecutive semesters in wind energy course, students were asked to present the back-to-back system in different and creative ways as a group activity. This course was held for master's and doctoral students in renewable energy engineering. The mentioned method must be applicable in e-learning. The back-to-back system was modeled in MATLAB Simulink using its built-in blocks. Now we come to the second part, the proposed method. For better understanding, the Simulink model is shown. In this method, each component of the system structure is linked to part of the bodies of two controllable rabbits placed side by side. The blocks IED-ref and IED-mes represent the two ears of the first rabbit, and similarly, the blocks IQ-ref and IQ-mes represent the two ears of the second rabbit. Moving downward in the model, there is a sum block, which is listened to the eyes of the rabbits. Since the sum block contains positive and negative signs, each rabbit has only one eye, symbolizing the positive and negative aspects within the block. The gain block, a triangle-shaped block containing the coefficient k, is placed after the sum block. In the puppet structure, this is positioned as the nose of the rabbits. Another sum block exists in the model, which is placed at the mouth of the rabbits. In this model, a secondary path is also visible. What is placed inside the rabbit's mouth is the teeth and the tongue, with the teeth resembling the triangular gain block and tongue resembling the square-shaped integrating block. Since the Simonic model pertains to controller subsystem of a wind turbine, the ears are connected with strings to a small hanger, reminiscent of controlling marionette puppets. Then, to reinforce the retention of the educational content, the rabbits are placed inside a box. In this section, we would like to explain the survey result to you. The postgraduate students present in the class were asked to participate in surveys and respond to 4 questions. The 5 options provided for the students reflected the level of the agreement with the statements in each question. The options were 1, that means very low, 2 means low, 3 neutral, 4 high, and 5 is very high. The survey results showed that this technical method was highly engaging. The majority of representatives were in high and very high categories, indicating the significant effect of this approach in capturing students' attention and interest. The use of handcrafted objects and their connection to complex simulation models successfully increased the students' interaction and attention to the object matters. This method significantly facilitated interaction between students and the instructor. Most students reported that this approach greatly improved classroom communication. Survey results revealed that the most students were able to easily recall the details of the simulated model and found complex control system concepts more comprehensible. Transforming abstract concepts into tangible objects helped students better understanding and retain the material, making it more memorable. This method was also seen as an effective tool for teaching other courses. Students agreed that this approach could be adapted to other engineering subjects, since the method makes complex concepts tangible and understandable. It has the potential to be applied to various education fields and topics, especially those involve complex system dynamics. Now we move on to the last section, which is conclusion. This study presents a creative e-learning method for teaching wind energy to control system. Using handcrafted model alongside MATLAB simulating, masters and doctoral students learned the generator controller in an engaging way over the years. Surveys showed this approach boosted the creativity, teamwork, concept retention, and simplified complex control system concepts. Thank you for your attention. I hope you found our innovative teaching methods for your research and educating. I'm happy to answer any questions or discuss how this approach can be applied in our context.